My name is Piotr Karwasz. I'm a member of the Apache Software Foundation. I mainly work on Apache Log4j and represent the foundation at ECMA's TC54 Software Transparency Group. Today I wanted to show you a demo of a project that I started with Munawar Hafiz of Open Refactory, which is called VEX Generation at Scale. Before we begin the demo, I wanted to tell you a few words on how vulnerabilities are handled in the Java ecosystem and what is the importance of the project for the Apache community. The Java ecosystem is known for having a lot of dependencies, so for a typical application having 300-400 dependencies is not something exceptional. Most of the ecosystem is composed of libraries that don't embed the dependencies, whereas applications ship their dependencies in their releases. So the handling of a vulnerability that could appear in one of the dependencies is very different between applications and libraries. Libraries just need to test that the new fixed version works, but applications have to ask themselves, do we need a new release? What they had to do, at least until now, is either to look for themselves if the vulnerability is exploitable, or to ask the artifact that had the vulnerability, which caused a lot of questions to people that not necessarily knew how the application used that dependency. To prove the situation, we used an idea that was circulating, which said, okay, why don't we get the other components involved? So libraries, yes, sure, they don't need to release a new version when a vulnerability is covered in their dependencies, but they can help. And this is what usually do. If somebody were to ask me if the vulnerability in SnakeYam was exploitable in Log4j core, I could have done the analysis and answered them. To test if my reaction was the exception rather the rule, we reach out to two dependencies of Log4j, SnakeYam and Jackson, and Apache Kafka, which is an application, to see if they are willing to produce VEXs, vulnerability exploitability exchange files, which automate the decision whether you need to release a new application version or not. These libraries are battle tested. Each one of them had some periods in time where they were submerged with CVEs and had to answer a lot of questions to a lot of people. So they willingly agreed, and what we want to gain with this project is an improved reputation, which was damaged by the CVEs. We want to have less duplicate security questions. If people don't have something machine readable that they can use, they will ask questions that humans need to answer. We also expect to have less work each time we have a vulnerability, since the other parts of the ecosystem will handle part of the work. And what Kafka can gain? Well, Kafka doesn't need to have so many releases each time there is a small vulnerability in its dependencies. Now we will show the work that we have already done on some SnakeYam vulnerabilities to show that they are actually not exploitable in neither Jackson, Log4j nor Kafka. For this project, there will be a portal where you can download the VEX statement generated for vulnerabilities in the 4 components mentioned before, so SnakeYam, Jackson, Log4j, and Apache Kafka. And in this demo, we will show how it works. So there is a prototype LLM that for each CVE looks for the root cause of the CVE. There is a call graph generator that can see how each library uses the other one. There is a reachability analysis script that puts those information together to tell you whether a vulnerability in one component, for example Snakeam, is exploitable in another one. Okay, so let's start with the first part of the demo. So whenever a new CVE is discovered, we need to go to the NVD database or another database to see what it's the description of the vulnerability. The one we have on the screen is pretty scarce. The description, we only know that there is a denial of service and that it's due to a depth limitation problem. So we have a prototype of an LLM where first we take the CVE number, then we start the LLM with the CVE number. What it will do, it will analyze the NVD database, potentially our database, to see all the related links to it, and if it finds a git commit or something like that, it can analyze code and tell us in which method the problem resides. Okay, as you can see, the LLM is running the analysis for the CVE 2022-25 857. It found a git commit linked, and now it will try to find which method was the vulnerable one. Yeah, we are analyzing multiple times the same data to see if it finds different results. It found the result, but it's not the right one. It's analyzed loader options as a Java class. This is a purely configuration class. It cannot be responsible for the CVE. It was modified because a new configuration options was added. Let's see if it finds the cause root. Yeah, it found the root. It's composer node. Compose node was we verified it was really the method that is vulnerable. In parallel with the CVE analysis, what we can do is to run the call graph generation. So to do that, we have a ready script. It's based on ICR Java and a small application, Android application, to make the run faster. So yeah, we want the results in result adblocks plus Android. The call graph generation, what it will find, it will analyze all the methods, and it will find which method calls which one, and the result will be stored in a JSON file, which will be a map from caller to callee. It takes some time, so we chose an application which has only 900 methods. What's the form of the result? It's pretty much universally reusable. We have the caller and the callee. Once we have the first two ingredients, we can add them up to have a magnificent result. So in a folder we have the call graphs of Kafka, Jackson, YAML, Log4j, and Snakeam, which each one calls the other. This is an example from Kafka. And what we can do now, we know which method is problematic. Compose node. We can simply run a reachability script and we'll see, yes, Snakeyam, of course it's vulnerable. But as soon as we go to Jackson, it's no longer vulnerable. Jackson uses Snakeyam directly, but it does not use the vulnerable methods. So the problem with exploitability stops there. Nobody needs to care about the CVE upstream.